Introducing O-rings. An O-ring is in effect a mechanical or engineering device that is designed to seal two or more parts. They are ubiquitous in machine design because they are inexpensive, easy to manufacture, and can be easily mounted between the parts. Rubber O-rings, as with those made of other materials, are almost entirely in the shape of a torus, which is a three-dimensional circle. As a device, O-rings are used in both static and moving applications, such as in pump shafts or hydraulic pistons. Perhaps their most important property is that they can face tens of millions of pascals of pressure. This equates to thousands of psi. To put this in perspective, a rubber O-ring which is properly installed can withstand pressures that are thousands of times that found at sea level. All O-rings function by keeping fluids and gases in or out of space delimited by the interface between the parts. For example, an underwater camera will use O-rings to keep water out, but the regulators used in scuba diving use O-rings to keep pressurized gas in the tanks. An important patented device. The very first patent recorded in the industrialized world was filed in 1896 by its Swedish inventor and independent scientist called J. O. Lundberg. The first U.S. patent was granted to a Danish engineer called Niels Christensen. Perhaps underpinning the importance of the O-ring device, it was not an easy ride for the engineer. He arrived in the U.S. in 1891, and after being awarded a patent for developing an air brake for trams, he became a full-time inventor. In 1933, he developed the rubber O-ring in the Chicago basement, but legal wrangling meant he never received the patent he deserved. In addition, after Pearl Harbor, the U.S. military intervened and gave other organizations the right to manufacture the rings. In compensation, the inventor received a paltry $75,000 payment. The dispute was settled in 1971 with a $100,000 payment to the inventor's family. How does an O-seal work? An O-ring is set into a groove or gap in the material used to make the equipment. When the O-ring is firmly placed into the correct position and the two surfaces are fastened or squeezed together, the pathway that the fluid or gas would normally flow through is blocked, or in some applications diverted. When the rubber seal is placed into the machine, it is not in its original shape, and it immediately tries, against the force of a solid material, to reacquire its original configuration. However, this setup means that the O-ring seals under low pressure. As soon as pressure is applied to the system, the O-ring is pushed against the material. The flow of gas or fluid pushes the O-ring against the aperture in a direction which is opposite perpendicular to its flow. This forces the O-ring to push against the structure, enabling it to withstand the pressure of the flow and seal the fluid medium inside or outside the device. This kind of setup is analogous to the water in a balloon. Water, as with all liquids, is not compressible. If you squeeze a balloon filled with water, there is movement in the opposite direction. The O-ring works in the same way. The pressure of a moving fluid forces the O-ring against the walls of the structure. http://www.birminghamseals.co.uk